I think you guys can hear me. Oh, this is neat. Sorry, just kind of like learning something new today. Didn't realize I can actually get the chat to come in the video itself. What's the time delay for it? Let's do 8:20, 25 seconds. All right, it's about 8-second delay. Right, sorry guys, just kind of like messing around with a couple of settings here, but so what are we going to be doing today? We are going to be doing mainly exponential equations. Today is going to be a bit of a short session, because as I said to you guys, like when I'm running like this many tutorials, usually I get to a point where I'm like, I just struggle to speak, and I had a bit of a long day at school today, which meant lots of talking, and by the nighttime my voice is like ready to crack. Yeah, I wanted to know where is Jason? He was asking a couple of questions about MCAT last night. So what we'll do is we're going to kind of have a look at sketching exponentials first. And the reason why we're doing sketching exponentials is because the last 2 years, I had a look at the 2019 paper was here. So 2019 paper, it popped up. 2020 paper, it popped up as well. And by the looks of it, they should be trying to think, are they achieved or merit questions? Because I can't remember for the life of me. So exponential equation, that's worth, yeah, it's worth an achieved. I think they dropped it. Yeah, see, because like in 2019, it was actually worth a merit, but in 2020, they actually dropped it to an achieved. So that kind of sucks. If you guys do have a graphics calculator, it'll be good for you guys to have it with you nearby, so we can actually go through this and kind of use the graphics calculator as well to kind of show you guys how to use that to sketch the exponentials. Yeah, and blocks, unfortunately, it's I can only this exams happening all this week, and it's like people are everywhere, so it's a bit hard to try and time it a day before your exams. Unfortunately, I'm sorry about that. All right, guys. So we're gonna get kick things off here, and I think that there's one more thing I actually wanted to add in this session, and I haven't seen that question come up last year, but it is a very useful skill to have, which is transformations of exponentials. So I'm just going to put that in there as a quick kind of like rundown of how that actually works. Cool. So yeah, I think we've got enough people in here to kind of kick things off. So the first thing we're going to be looking at is sketching exponentials. So with sketching exponentials, what they tend to do is they kind of give you guys the space here to work with. I'll show you what the exam paper looks like so you get an idea. Where is it? Yeah, here we go. So what they tend to do is like one of the questions, they will give you guys a bit of space like this. And then in this space, they will ask you guys to draw a particular graph. So this graph here right now is like y equals to 3x, 3 to the power of x minus 1. What we'll do is we'll do a slightly different one. So we'll do something like y equals to 3 to the power of, actually not 3, let's go 2. 2 to the power of x plus 3. Of course, hang on, something's just frozen up here. Give me a second. Yep, I think my new tablet should be arriving some point, but preferably before before the end of the year. Yeah, so here we go. That's much better. So let's say we want to actually try and solve this, sketching this exponential, right? So what you're going to have is you're going to have some sort of grid there. Now I mean, I'm a bit lazy at the moment, so I'm just going to kind of rough sketch it for you guys. But for you guys, you'd have to be a little bit more accurate. So a couple of things to notice is that for sketching exponentials, if you have a graphics calculator, then you can actually get all the values already done for you on the calculator. And if you don't have a calculator, then if you don't have a graphics calculator, then you'll have to do a little bit of extra work. But it's not too bad. I'll show you guys some a few little hacks here, right? So the first thing that we're going to do is I'm going to show you guys how to get a table. I was going to show you guys how to get the table from the graphics calculator. So click on menu, and under menu, what you want to do is you want to go to the table mode. So if you go down to the table mode, click on that, and what it'll ask you for is like put a function in there. So the function we're going to put is this one here. So we're just going to make sure we put 2 to the power of x plus 3. Now this is really important that you guys actually put the x plus 3 in a bracket, because if you don't put the x plus 3 in a bracket, then the calculator would actually think that this is what you're trying to put. If you don't put the no brackets, means the calculator is going to think this way. So that's why we want to actually make sure we put that brackets and we put x plus 3. Once that's done, the other thing that's also worth noticing is that you know how your like, I'm going to go back to this diagram. So if you guys have a look for this particular question, they've started from -2 to 5. So it's like if you have a grid like that, then I would say that you probably want to start from -2 to 5. And again, if you look at the 2019 paper, they're actually going from -3 to +4. So that's another thing that you can do. I hate fireworks, man. I honestly do, because it's like, yeah, it's just freaking annoying. I can't do any recording during this time or tutorials. It's just messy, and it's going to get a bit more crazier. So that's why I'm going to run this quickly, guys. So like I said, you know, each exam paper, the X values are going to be different. So what you want to do is like, you want to make sure you look at what's the lowest amount, what's the highest amount, and then you're going to adjust that on your graphics calculator to give you like the best value. So let's say your axis is like going from, I don't know, -4 to 10, for example. All right. For example, what we can do is in your graphics calculator, the F5 button is what we call the set button. You can click on that and you can actually put down what your starting point and what your end point is. So in other words, what happens is this is your starting point. This is your end point. So I'm going to put in start as -4 and then the end as 10. And again, this is just to give you guys a rough idea, right? And I click on enter, then I click on table. And what you guys will notice is I've actually got the entire table of set of coordinates that I can use to draw this particular graph. Now, obviously, when it gets to 5 and when it gets to 10, it's going to get like really big. So you kind of just, what you do is like when you sketch it, there are some important points that you need to make sure you get. The first important point is the y-intercept. So in this case, it's like at 8. So I need to make sure that that graph is actually cutting at 0, 8. All right. And then the next thing is kind of like sketching the graph. So if you have your points kind of like set up, then what you should be able to do is kind of like get a nice smooth curve going. So really, sketching exponentials or sketching parabolas, if they ask you guys to do those things, you guys can pretty much use this method here, which is just put it in the graphics calculator, get the table, get the values out, and then you're good to go. Okay, let's imagine that you suddenly forgot how to use this graphics calculator and you're like, oh man, I know Infinity Plus One talked about this, but I can't remember it. The other way you could do it is also create your own table. So you could actually say, I'm going to create a little table. I'm going to put down X and Y, and I'm going to choose what my start values are, -4, -3, -2, -1, and so on. All right, that's another way you could do it as well. But the pain of this is that for each individual number, you would have to go in there and type it in. So for example, you would actually go 2 to the power of -4 plus 3. So that's 0.5. Then you would actually go into, just press the back button, get rid of the 4, you replace it with a 3, press enter, 1. And on the odd occasion, you guys will start seeing patterns appearing. And if you do see patterns appearing, then you kind of know what's happening here. So in this particular case, you can kind of see a pattern appearing after this number. What's happening is if you look at all the Y values here, they're all multiplying by 2. So straight away, I can just kind of go guess this is 8, 16, 32, 64, 128, 256, and so on. So yeah, so that's pretty much how you look at doing sketching exponentials. So if you guys see a question on sketching exponentials, basically you can do a table. So do a manual table, or you can do a graphics calculator table. You don't need to copy down the graphics calculator table. You can just use the values from the graphics calculator and just plot the graph. Do you guys have any questions on that or any kind of troubles with that? If not, then I can move to the next part of this tutorial, which is forming equations. Cool. Jason, Bobby, you guys are both from Selwyn, eh? They've gone quiet. Radio silence. Wait, how many of you guys are from Selwyn College here? Yeah, I know you're from Selwyn, Jason. I remember that. All right, guys. What we're going to do is, if we're all good with sketching exponentials, I might just head over to forming exponential equations. Mr. Minton. What's his like, see, I always get mixed up with his name. Is Minton first name or last name, man? Bobby? I'm trying to think of this person now. I'm getting sidetracked. Okay. What I might do is Ashley Minton. Oh yeah. I remember. Yep. That was a long time ago, man. I came and visited the school back in 2017. It was nice to come by and walk the good old hallways and memories. Anyway, let's go to forming exponentials. So what we're going to do is I'm going to start off like very basic with you guys, because the way I kind of teach forming exponential equations is a little like tricky, but once you get the hang of it, it's pretty much you're sweet. You're good to go. Just give me 1 second. I just need to set up the question, and then we should be good to go. Actually, no, I'm going to come back to here. Okay, so what I'm going to do is this. I'm going to put up a table for you guys, and I'm going to ask you guys to kind of have a go at this. All right, I'm not going to tell you guys anything apart from it is an exponential equation. And what I would like you guys to do is yeah, I'm gonna ask you guys to try and do this. So give me 1 second. I'm just trying to get the numbers out, and then we should be good to go. Y1, there we go. ARX1. Why is this not working? Defined elsewhere in the calculator. Oh, f of x. Sorry, guys. Give me 1 second. It's just a little bit annoying. I'm not having fun today with this thing. Okay. Let me just do this old school, eh? Give me a second. I had the file before, but it's just gone, disappeared. Cool, guys. So this is the question that I'm going to pop up for you guys, and what I would like you guys to do is come up with the equation for this exponential series, right? So try and have a go at it. And again, if you don't remember how to do it, or you're like, geez, I can't remember this at all, that's not a problem. Just write down what you think the answer is going to look like. And I'm going to give you guys a couple of minutes while I just sort out this table. And then we can actually go through to try and figure out how to do some of these questions. The problem is I have too many accounts, and I'm just trying to find which account did I save this freaking file in. It's not this account. No save graphs. Where the hell did I put it? The only other account I can think is this one here. Here we go. Got it. F of x equals to ARX. Brilliant. Got it. Now I've got the file, so we're good to go. All right, so I hope you guys have had a bit of a chance to go at it. I know it's been a bit messy, but yeah, look, we'll go through this. So basically, remember how when you have a straight line, you remember you'd have y equals mx plus c. When you have a quadratic, you've got y equals to ax squared plus bx plus c. Now, in your class, guys, or in your schools, you might actually see a completely different version of this equation. And if you're comfortable with it, that's absolutely fine. And if you're kind of like, I need to learn this all over from scratch, then I tend to use the y equals ARX plus C. And I mean, it just it works. And I'm going to show you guys how to calculate each one of these variables, right? Like how you're going to calculate R, how you're going to calculate C, and how you're going to calculate A. So our first step here is having a look at the value of C. And, you know, it's really, you can get like things quite mixed up. So what I'm going to do is like, I'm going to show you guys like a couple of ways. So the first method I'm going to show you guys is substitution. So I'm going to take 0, 4, and I'm going to substitute in this equation. So when I substitute 0, 4 in this equation, I'm going to get 4 equals to AR to the power of 0 plus C. Now, the issue that I have here is if I take another point, so let's say I take the point 1, 8, and I substitute 1, 8 in there, I'm going to get 8 is equal to, I'm going to get 8 is equal to AR to the power of 1 plus C. So here comes the problem. The problem is that I've actually got three unknowns here. I've got A, that's unknown. I've got R, that's unknown. And I also have C, that's unknown. So there's actually three unknowns. So what we've got to do is we've actually got to figure out one of the things by another method. And the way we're going to do that is by actually looking at these values here. All right. And this is really important for you guys to kind of pick out what's happening to those numbers. So basically, I have a look at those numbers and I can see that they're doubling. Now, if you're not sure about it, what you could always do is take the second number, which is 8 in this case, and divide it by the first number. And then try it again with the third number divided by the second number. So in this case, it's going to be 16 divided by 8. And if you were to keep going like that, if you go 64 divided by 32, you can see that it's always increasing by a ratio of 2. All right, so in that case, what we can say is that R is actually equal to 2. So if that's the case, then we have two equations here. Our first equation is 4 is equal to A, 2 to the power of 0 plus C. Then our second equation is equal to 8, A, 2 to the power of 1 plus C. So with that in mind, what we can then kind of do is we can actually get rid of the 2 to the power of 0 and 2 to the power of 1, and we rewrite it as 4 is equal to 2A plus C, sorry, not 2A, 1A plus C, because 2 to the power of 0 is 1, and also 8 is equal to 2A plus C. Now at this point, you've got a set of simultaneous equations, and remember that if you were kind of using algebra, like if you were in MCAT, you're not allowed to use a graphics calculator, so you'd have to do this the long way. But you are allowed to use the graphics calculator. So what we can do is actually substitute this in simultaneous equations. So if you go into equation, click on F1, which is simultaneous equations. Number of unknowns is 2, so I'm going to click on that. And notice how it says like AX plus BY plus CN. So all we're really doing is we're going to have to rewrite this a little bit as A plus C equals to 4 and 2A plus C equals to 8. And what we are going to do is we're going to use this as A, B, and C. And if you think about it, the numbers in front of A is 1, C is 1, C is also 1 there. So I'm going to put those numbers in. So I've got 1, 1, 4. Then I've got 2, 1, and 8. So when I do that, I get these two. So notice how it says like X and Y is 4 and 0. Now X and Y, in this case, this is X, like this A is equal to X and C is equal to Y. So then what we can say is that A is equal to 4 and C is equal to 0. So with that in mind, we've actually got our equation. So Y is equal to 4 multiplied by R, which is 2 to the power of X, plus 0 is what our equation is. Now, I see that there's actually another answer from Simon 101, which is, Simon, I'd say to you that you just need to make sure that X plus 2 is in the power, or putting a bracket around it. So, and if you can actually see, this was Simon's equation, which was 2x plus 2. Now, both of these equations here are the same, because think about it like this. This 2x plus 2 could be written like this, 2 to the power of x multiplied by 2 squared. Because remember, that's what we did in algebra, when the powers get added up if the bases are the same. And then we can say that this is going to be the same thing as saying 2x times 4. And what you should see is both of these equations are the same equations. So that's to do it with a graphics calculator and how do I say it? With simultaneous equations. The other way you could have done it is from this step here. What you could have done is, so I'm going to put this as manual here at the moment. So I'm going to write the bottom equation at the top first. So 8 equals 2a plus c, and then 4 equals a plus c. And if I just do subtraction of the top equation minus the bottom equation, so 8 minus 4, 2a minus a, c minus c, what I'm going to get is 8 minus 4 is 4, equal sign stays as it is. 2a minus a is just a, and then c minus c is 0. So I can see that a is equal to 4. And because a is equal to 4, I can go 8 equals 2a plus c, and then 8 equals 2 times 4 plus c, and I'm going to get 8 equals 8 plus c. So this actually gives me c of 0. So this is just the manual way of doing it. You guys can do it manual or graphics calculator. It really doesn't matter, as long as you can get to this answer. Some people can just look at the values and straight away predict what it is. That's absolutely fine as well. If they ask you to come up with the equation of an exponential. Shall we do a couple of problems on this? And then we can actually go on to the other parts. The other parts are fairly quick, but it's this part that's really important that you guys get the hang of it. Cool. So I'll leave the working up here for you guys, so you guys can actually kind of see it on the side. And I'm going to give you guys two problems to kind of work on, so that we've got enough kind of like time to go through both of them. So the first one I'm going to give you guys is yep. So that's A there, and then B. So there's those two questions for you guys. Just I would like you guys to actually come up with the equation of those two tables there. Simon, as I said to you, it doesn't really matter as long as you put that x plus 2 as a power. So if you were to write the previous answer like this, if you wrote it like this, then you're actually incorrect. But if you wrote it like this, then you're on the right track. Why do you know? Made by Ben. I'm not actually understanding your question. Could you clarify that a bit more, mate? The tables made by Ben, it's actually given to us. Like, so that's what I gave you guys the question as, so that you guys could actually have a crack at it. Ooh, M19, nice work, Joel. Congratulations. Two to the power of x plus 3. I'm not liking that plus 3, Bhargav. Check, some of you guys are getting the values correctly. I'm just worried that you're not writing the actual, the formatting of that answer properly. Nice, we're starting to click along nicely, folks. All right, guys, I'm going to go through question A, just because I'm looking at some of you guys' answers and like, a couple of them are on point. A couple of them, you're just writing it in the wrong format. So it's just to kind of go through that part again. We should be okay after that. Okay, so the first thing is having a look at this question, right? Now, here's a good question. How do we know if a table that's been given to you is whether it's an exponential, whether it's a linear, or whether it's a quadratic? So my simple kind of tip for that is this. It's you gotta you gotta have a look at your y values and then see what's happening to the y values. So if it's linear, when you subtract the y values, it'll always be the same. So for example, I've got 3, 6, 12, right? So I can see straight away this is not linear, because the reason it's not linear is because it's going plus 3, plus 6, plus 12, and so on. So that's my first thing. I know this graph is not a linear. How do I know that how do I know if it's a quadratic or or if it's an exponential? And I guess the best way to do that is to have a look at the difference. Like, I mean, there's a couple of ways you can do it. I mean, sometimes you can just look at the question and you can kind of see straight away these numbers are actually doubling. And if you get a feel for it, you can straight away kind of go, yep, that is on point. Yeah, that's doubling. So because these numbers are doubling, before even starting this, I'm going to put down r is equal to 2 in this case. So let's go to our equation. Our equation is y equals to arx plus c. We're going to take 2 points. I'm going to take 0 and 3. So 0 and 3, when I use that, I'm going to get 3 equals a times 2 to the power of 0 plus c. Then I'm going to choose 6 and 1. So I'm going to get 6 equals a to the power of a times 2 to the power of 1 plus c. All right, so this just pretty much the equations are, I've got a plus c is equal to 3, 2a plus c equals to 6. So at this point, I could go straight into the simultaneous equation solver, and I'm just going to do that. Our number of unknowns is 2, so I've got 1, 1, 3, and then I've got 2, 1, 6. So what I've got is 3 and 0. So this is telling me that a is equal to 3 and c is equal to 0, which means my equation for question number A is going to be y is equal to 3 multiplied by 2 to the power of x plus 0. Now, as I said to you guys, I noticed a couple of people putting x plus 3. I think Bhargav, I think you got the 3 correct, but it was just the wrong, I think you put it in the wrong letter. So you need to be careful with that one, all right? So just make sure you put the right values for the right letters when you're substituting it back. And also the other thing I would say to you, Bhargav, is like check your answers. Like, see, you know how you had your equation as y equals 2 to the power of x plus 3. Substitute it, like take a value. So let's say I take this value here, 212. So if I put 2 to the power of 2 plus 3, is it equal to 12? I'm going to get 4 plus 7. So I can see that 12 is not equal to 7. Therefore, I know that that equation is not correct. So that's a really good way to do is once you get the equation, go back and actually check it. So yep, Bobby, that's all good. 3 to the power of 2x is what I was looking for. Looking at question B, I'm looking at what's happening with those numbers. Those numbers are tripling. If you're not sure, then just go into your normal calculator mode and just go 15 divided by 5, 45 divided by 5, 135 divided by, no, not 45 divided by 5, sorry. It should be 45 divided by 15. And then 135 divided by 45. So you can see that it's increasing with a ratio of 3. So I'm going to put down r is equal to 3. So I've got y equals to a, r is 3, x plus c. I'm going to take 2 points. So I've got 0, 5. So I've got 5 is equal to a, 3 to the power of 0 plus c. I'm going to take another point. And let's say you stuff up and you're like, you know what, I don't want to use 115. I want to use 3, 135. That's fine. Let's use that. Right, what we're going to get is 135 is equal to a, 3 to the power of 3 plus c. So now we're going to just rearrange it a little bit. So we're going to get a plus c is equal to 5. 3 cubed is 27. So 27a plus c is equal to 135. So let's try that in the graphics calculator to see what values we get. So we've got 115. I've got 27, 135. So as you guys can see, it doesn't matter which values you use. Because you're using simultaneous equations with the graphics calculator, it's just going to spit out the values. So our a value is 5 and our c value is 0, which means our equation is y is equal to 5 times 3 to the power of x. Cool. You ready for a couple of more tricky ones? Because let's face it, that's what they're going to be throwing at you guys, right? So this is like your nice and straightforward ones. Okay, here we go. Tricky one coming up, and I might actually walk you guys through this if you guys do get stuck. But you know what? I think you guys will be all right. Okay, so with question C, it's just going to be a little bit different, but I think you guys got this. There we go. I'm going to leave that out for you guys. And I'm going to give you guys about a couple of, maybe 5 minutes to try and have a go at that. But pretty much exactly the same thing as what we've done so far. Hey, Jason, who's all your DPs at the moment at school? Actually, any Selwyn guys. Yeah, deputy principals. I was trying to look it up online and trying to see which people. Mr. Henry was my geography teacher back in 95 when I was in year 11. 95? No, 96. Bobby, figure out the R first. Once you figure out the R, everything else is the same after that. So just look at the numbers, but mainly look at the difference of the numbers and see what's happening to the difference of the numbers. Because that's it, right? I mean, think about it. The most challenging part of this question is to figure out the R value. Once you get the R value, then it's just straightforward substituting it into the graphics calculator or by doing simultaneous equations and you're good to go. So if anybody wants to throw out what they think the R value is, then that might be a starting point. So let me show you this, Bobby. I know how to do, but I just can't. I don't understand that, but let's try it. So if you look at the differences, right, you've got +3, +6, +12. So that should give you a very good clue of what the R is. And I love how we've got quite a few different answers here, which is always the fun part of live streams, because when other people are putting their answers up, you're like, man, how the hell did they get that? Did I make a mistake? Did they make a mistake? And then you go check your answers, right? That's the cool part about this. So anyway, Bobby, I hope you got that R value there. So if you guys didn't get the R value, sometimes a good idea is to have a look at the difference between the Y values. So when you look at the difference between the Y values, you've got 3, 6, 12, which is basically telling you that difference is actually doubling. Because it's doubling, we can say that R is equal to 2. And because R is equal to 2, then it's just pretty much bread and butter for us. So we're going to go a to the power of 2x plus c. We're going to take 0 and 5. We're going to put 5 is equal to a 2 to the power of 0. 8 equals a 2 to the power of 1 plus c. We're going to rewrite this as a plus c is equal to 5. 2a plus c is equal to 8. Chuck it on the calculator, and we should be good to go. Oh, no worries, Tom. Did my video just disappear? That's really... Can you guys see anything, or... What the... This is new. I've never faced this problem before. Okay. What if I was to refresh stream? How long has the screen been gray like this? That's so weird. I've never seen a gray Okay, I might just stop the stream. It might just go dark for a while. Let's see if I can fix it. There we go. We're back. That's insane, man. I've never seen that gray thing happen before. I'm sorry, guys. I know I kind of like rushed through that. I don't even know how much of it that you guys actually missed. But just to kind of recap, that 3, 6, 12 in the red there, that actually gives us the ratio of 2, that it's increasing by 2. And then I've just substituted the points and rearranged it. Then I've got the calculator, and I'm just going to chuck in 1, 1, 5, 2, 1, and 8. Basically, that gives me 3 and 2. So that basically is saying me that A is equal to 3, C is equal to 2. You might need to just click on the settings and just change the resolution. It should be back to normal in a few minutes. Cool. So once we get that, we've got y is equal to 3 times 2 to the power of x plus 2. That's what I'm looking for. Cool. Are we up for another challenge question? But this time I'm gonna make it a little bit more, no. Kind of like make it a little bit more trickier. What do you guys reckon? Or do you want another question like similar like this? Okay, a little bit trickier, but still the same rules. All right. So bear with me. Let me just pull out the question. I might start with a simple one first so that I don't throw you guys completely in the deep end, which people definitely hate me for. Let's try this one here. -3. Ah, stupid thing. Okay, you know what? I'm actually going to throw you guys in the deep end. Let's try this one here. So we're going to get yep, that one there. See if you can try that one. So I guess the only tricky part is the R part, and I'm going to kind of leave it to you guys to kind of have a think about it. Yes, Tom, it is. I think it's on the whiteboard. Ah, that's a cheeky way of doing it, Bobby. I like it. No, Tom, I was teaching high school. Now I'm an intermediate teacher, and the most maths that I teach in a day is probably at year 9 algebra. Yeah, nice. Liana, I think you got it. There you go. That's one way of doing it. So interestingly enough, Bobby, the answer that you put up and the answer that I'm going to put up and the answer that you're going to see from some of the other people, there's going to be so many different versions of it. Um, but eventually it's going to come up with the same thing. Why did I change high school? Because I wanted to teach NCEA maths without having to mark it, without having to worry about internal assessments, without having to worry about getting kids ready for external assessments. Like I really enjoy what I do right now. Like I can teach any kid, and the guys that actually come here right now, like the people that are here, the 34, 35 people that are here, they actually want to learn. So it makes it easy for me. I enjoy what I do, and but in my class, I'm sitting there trying to kind of get people to get through it, and it's a lot more, yeah, like it's a different stress. So this is not stressful. This is enjoyable. And plus, I'm having a freaking amazing time at my new school, so I'm learning a lot of different things. So it's kind of given me that flexibility to grow. Ah, nice. Okay, see, that's the one I was looking at. Simon, Bobby. I hope you guys can see that both of your answers are actually the same answer, but just written in a different format. And if you guys can see the connection between both Bobby's and Simon's answer, um, that's like really cool. Every time people say that, like I always think about I always throw Dark Knight references, but like yeah, it's like I'm not a hero, man. I'm just doing what I can. Oh, that's interesting. Yep. You can do that too, Simon. That would work as well. But I'm really curious to see if anybody has a different one at all. Like everybody's putting 42x, which is quite cool. And sometimes you might get the answer for this one as 5 times 2 to the power of x plus 3 as well. And I'll show you guys why that's the same as 40 over 2x. Okay, anyway, let's go through this. As you guys would have figured out, r is equal to 0.5 because everything is getting halved here. And then we're going to chuck it into our equation. So let's not write in red, that's just rude. Let's go with blue here. So we've got a 0.5x plus c. Then taking our points, we've got 0 and 40. So we get 40 is equal to a 0.5 to the power of 0 plus c. Then we've got 1 and 20. So we got 20 equals a 0.5 to the power of 1 plus c. This could be rewritten as a plus c is equal to 40. 0.5a plus c is equal to 20. Chuck it in the calculator, and we are pretty much good to go here. So what do we got? 1, 40, 0.5, 1 and 20. So as you guys can see, you're getting a is equal to 40 and c is equal to 0. So straight away, your equation there, nice and simple, 40 to the power of 2x. Now, as I said to you guys, like we had quite a range of answers there, right? Ah, stupid thing. Thanks, Liana. I am really desperate for this new freaking tablet to arrive, man. It's dying. It's dying. Yeah, no worries, guys. Just refreshing it. It's finally dying, this tablet. It's like 6. It's the tablet that's the problem. It's not the computer. The computer is fine, but the tablet is just dying. Anyway, um, yeah. So hopefully you guys kind of got their bits there. But I wanted to show you guys why how Bobby got his answer, and we've got a couple of different versions of the answer, right? And I just realized that's not 2, that's 0.5. So remember that 0.5 is the same thing as saying a half. So what it is that when you have like 40 multiplied by half to the power of x, this is the same thing as saying 40 multiplied by 1 over 2 to the power of x. Same thing as saying 40 over 2x. Don't worry about the 2, I think, Simon. I know that they don't we don't talk about negative integers till about level 2, so they kind of drift away from it. So, but that's fine as long as you write this. The other answer you could also get is y is equal to 5 times 2x plus 3. Because the reason why you get this answer, why do I keep going to 2? 0.5x plus 3 is another version that you could potentially get. Let me just check that if I'm doing that right or wrong. No, not x plus 3, x minus 3. Yeah, so that's another, potentially you could get like another answer like that as well. But doesn't matter. If you get 40.5x, you're pretty much good to go. Okay, so the last bit that I wanted to talk to you guys about today was just the idea of transformation of exponentials. That's number 3, right? Like the next part is only going to take us about 5 minutes, but it's going to be very handy for you guys just to watch this visually and also possibly possibly take some of the notes down. But I think I have got the notes from previous tutorials, so I'm kind of going to share that real quickly. If I can remember which year it was. Was it 2018? God, was it 2018? No, it wasn't 2018. Must be CK Whiteboard 2019, revision 2018. Tables, equations, and graphs. Is this the one? I had a summary of it somewhere. So I just want to show you guys this here, right? Actually, this is a good one to show. So I guess there's a couple of things that you guys need to remember, and this is quite handy to kind of keep in memory or like just kind of take it down somewhere. And if that ever comes where they say, oh, what happens if you take this graph and you shift it 2 units up? All right, so if we were to move it 2 units up, then let me just change this up. Give me 1 second. Can we see a mouse? No, we can't see a mouse. I hate this thing. I just have to use a highlighter. So basically what we're talking about is like when they say increase by 2 units up, then that's the change that's actually happening. So you're basically adding 2 to the end of the equation to shift the graph up by 2 units. When you want to move it down, if you want to say move the graph 4 units down, then you would actually subtract 4 from the whole equation. When you want to move the graph to the right by 3 units, you would subtract by 3. And if you want to move the graph 5 units to the left, you would actually add 5 to the power. All right, now if you guys want to take a screenshot of this, you can. I mean, these notes, these are actually some of my old notes, which I think some people might. I don't know if you can get access to it. Let me just check. Is the 2018 paper there? I don't think it is. So you might not be able to get access to this document, but you can actually take a screenshot of this. And this theory, it also works for quadratics. It also works for straight line equation and so on. And the other thing that's really important is this part right here. Sometimes they'll say, what happens to the graph if you want to reflect on the x-axis? So if you want to reflect on the x-axis, then you change the y to a negative, or the other way to do it is like put a negative in front there. That would actually reflect it on the x-axis. And if you want to reflect it on the y-axis, so reflecting the graph on the y-axis, you would actually change this. Now what I'll show you, I'll actually show you guys what it looks like. No, unfortunately, this is actually from one of my old notes. I will, you know what? I will just copy it and put it in that notes right now so that you guys can actually get it. I'll copy the whole thing, wherever that is. And I'll just insert it into the notebook. Oh, come on. How do I even, let's just see if this works. I keep thinking I need to make a infographics of this or something like that. Control copy. Let's see if we can put this in 2021 whiteboard. Here we go. Yeah, I'll put it in today's somewhere there. Yep. So it is in today's notes, guys. So you can actually go and access that from, what do we call this? Transformations, is it? Yeah, transformations. Yeah, it's very useful to kind of like, maybe if you guys get it some time later on, just go through and have a look at that transformations, because it is very, very useful. All right, because later on I actually talk about quadratics as well, how to actually move quadratics up and left and so on. And the last bit that I wanted to talk to you guys is just, I'm only going to go for another couple of minutes, guys. Yeah, so the increase and decrease by a rate. So this is the last thing that I wanted to, and this is a real quick one. So it's not like too tedious. So sometimes you'll have like, they'll say like somebody starts with $100 and they're going to increase their savings by like 15%. All right. And sometimes it might be like you buy a car. So this is for savings. And if it's increasing, then your equation ends up looking like this: 100 times 1.15. Now you might have done this in number. And so it's pretty much the same kind of concept behind it. So you're just going to go 100 times 1.15 to the power of x. Or in this case, they might actually put t. But if you think about it, this equation is the same equation as ARX, that the one that we've been working on so far. A being the starting value, R being the rate, X being the time in this case. And then the next thing is when we're doing decreasing. So let's say you buy a car for like $10,000 and it's decreasing by 20%. So this one is important again, because what we're going to do is, in this case, it's actually going to be 0.8 t. And the way we get 0.8 t is we actually go 100% minus 20%, which is actually 80%. So that's the rate at which it's actually decreasing by. So that's why we put it at 0.8. And how did I get that 1.15? It's actually 100% plus 15%, which actually equals to 115%, or 1.15. So that's where I'm getting the 1.15 for increasing by 15%. And then for decreasing by 20%, I've got to go 100% minus 20% to get 80%. And of course, 80% is the same thing as saying 0.8, which is what goes in that little formula. Cool, guys. Look, that was just something that I just wanted to quickly rush, kind of like run through by. But really, I think the main part that you guys should think about is the sketching the graph, getting the equation, and kind of having some transformations under your belt just so that you feel comfortable about it. And the last bit is the increasing and decreasing, like working with rates. And majority of the exponential questions, they end up dealing with money, or sometimes they deal with population and so on. So yeah, so that's pretty much it from me for today. What do I got? Oops, I just shut down my whole console, which means I can't see any of your chats. Far, am I having one of those days? Content. Sorry, guys, I can't even see the chat right now. Lovely, Subhash, lovely. What are you up to? Sorry, guys, just give me 1 second. I'm just trying to figure out where. There we go. I got the console back. I closed the wrong one. When am I going to stream next? Yeah, that's what we were getting to next. Where we got. Tom Bhargav, where is it? Desktop. Here we go. So today we did TEG exponentials. Come Sunday, we're going back with the level ones to do some more geometric reasoning. We'll be doing, most likely we'll be doing, I'm spending that entire session on, what is that blooming thing with bearings? That's the one I'm going to be doing. So we're going to be doing bearings on Sunday, and then level 2, I see you guys on Monday, then level 3s and level 2s back again. Yeah. Cool. Just did the TEG mock. How was it, TEG? How was the TEG mock? No worries, Sophia. Catch you guys on Sunday for the geometric tutorials. Tom, it's always going to be 8, man. Unless I have like my kid does kind of need me to read his book a little bit later, then that becomes a priority. Otherwise, 8 p.m. is when we kind of kick off with. Mila, the p to the power of x plus b plus c. Um, just give me a second. I'll kind of show you. I'll kind of show you how to do that thing, right? Because you know what so this is my equation, right? So like if you look at it here, what you'll notice is if you were the y equals to p, let me go back to your equation, p to the power of x plus b plus minus c. Okay, p to the power of x plus b, and then you've got plus c. Okay, the difference between your equation there and my equation is this. When you have p to the power of x plus b, it's the same thing as saying px multiplied by pb plus c. Now, pb is actually a constant. I just realized you guys actually can see it. Here we go. Let's try this. So when you have px plus b plus c, right? Then what you can then say is the next line is this becomes px multiplied by pb plus c. And then y is equal to, what I've done in my one is I put the pb in front, px like that, plus c. So if you think about it like this, my equation is arx plus c. So in other words, your p to the power of b is actually equal to a, and your p is the same as my r, and your c still ends up being the same. I think you guys can see it now. Is that right? Yeah, so that's the only difference between those two formulas there. So if you started off with like px plus b plus c, it'll still work. And I'll show you guys a question that we did earlier. Where was that question? Here we go. So if you think about this question right here, someone had actually written y equals to 2x plus 2. Now, both of these equations are the same. And I'll come back to what I mean by here. Where did it go? There we go. So it's kind of thinking like your equation that you had was 2x plus 2, and my equation here was 4 times 2x. Basically, both of these equations are the same because here I could rewrite this as 2 to the power of x multiplied by 2 squared, and then which equals to, I'm going to bring 2 squared to the front, and guess what? I've got 4 times 2x. So yeah, that's I hope Mila that actually made sense with that. But basically it's the same equations. It's just people write it differently. And that formula that I kind of messed around with is like I try to make it as easy as possible so that kids can actually kind of solve it straightforward without having to worry about that horizontal movement. Because in your formula, this plus b right there automatically does the horizontal shift. However, in my one, I don't actually have a horizontal shift. It just goes A straight away. Cool, guys. That's basically it. I'm going to catch you guys on Sunday. It gives me 3 days to rest my voice a bit. Yeah, throat has gone a bit bung. Need to get some nice lemon tea or something like that. Level 1 chance and data. Yes, good question. Who was it that was... she's still doing it as the question. Let me just check. Check out this person here. Let me just see if she's actually uploaded any level 1 stuff. Yep, she should. I'll chuck it up here for you guys. Give me a second. So she does old work colleague of mine. She does a lot of stat stuff, so go check her stuff out. Bobby, 2021 mocks. I don't like. I'm very mindful of doing mocks during tutorials because what happens is the mocks are actually purchased by schools, and so it's actually copyrighted material. So I theoretically can't go through mocks. I mean, I go through NZQA papers because they're available freely on the web, but I don't go through mocks because, yeah, I think I'll get into a bit of trouble with them if I start making videos on that because they actually make money from selling those papers. All right, guys, that's it from me. Have a good one. I will see you guys on Sunday for geometric reasonings. What is it? Bearings. My favorite excellence question ever. Have a good one, guys.